Okay, let's continue. So in the previous exercises, we created a couple of libraries and then linked against them to use them in an executable. And in this example, we're going to make another library. We'll call it beat it in example 7, and then we'll link against it in example 8. So the main difference here is that this library isn't going to have all the bells and whistles that are needed in order to make a configuration that can be used in a find package command in a downstream project. It'll simply build the project and directly install the library and the header file to the locations that we want. So if we look at the CMake list.txt, it's more of the same. We have the CMake minimum required. We give it a project. We set a couple of variables, and then we tell it where we want to install it. In this case, the main source directory, and then we go up to user example 7 in this case, and then we have this add subdirectory, which is going to give us the this source here. So this new class is like the old one. It has a function called hi there, and when you call that function, it simply outputs beat it. Okay, so then we come up to, if we look at the CMake file for this, we're making a static version of it, and then nothing fancy, just copy and paste everything to make a shared version also, and we've renamed it shared with a shared extension here and without the shared extension here. So that's the main difference. Copy, paste, and change the names. So then, as similar to before, we target sources. So we created a library target called beat it, target sources, and we give it with the private tag the name of the source file, and then with the public, we tell it that it has this file set, which are the header files, and this will take care of both assigning the header that is needed by this target, both to build the target, but also telling it to telling it about them so that it can be used by downstream projects, and that'll be part of the installation. We'll see that in a second. That parallels what we did in the previous ones. And of course where the location is, which is our current source directory. So we set up the sources and the header files, and then include this GNU install dirs, and we tell it to install this target as well, and it'll put it in the default locations, which will be in the CMake prefix path, which in this case is upper directory and user, and then /example7. And then we also tell it we also want to put the file set, beat it headers that we defined up here, right there. We want to put those in the that same directory /include, and we'll look at that in a second. And then we do the same thing for these shared libraries, the shared version of the library. Okay, so that's it. There's nothing particularly special here. It's a simpler case of example 3 and 4, where we just have the one install command instead of the extra install commands that has the that installs the configuration file. So if we do that, let's go up to build, cd dot make a build directory, build, and then go mv direct build, and then go into it, CMake dot make install, and now if we go up 2 directories into our source tree here, we can see if we look in the user, we now have example 7, and example 7 in the include has the library, the header file, and in lib we have static and dynamic libraries. This time there's no CMake folder that was needed for the find package command, so it's good to include that, but here's just a simple example not including that. So there's the library. Let's go up and try it out in the example 8. So if we go into example 8, then we can see here we're going to connect this example, And in example 8, we're going to, well, anyway, so let's look at the CMake lists, same sort of thing. And then if we look in the source, if we go into, let's look at use beat it. In this case, the same thing, we'll link to that library, look at the CMake lists.txt. So we're going to add an executable, use beat it.x, give it the sources.cc, and then before we could use find package, and it would find both the library and its required header files and all the paths that are needed for all that stuff. That's all we needed. Now, because we didn't provide it with configure information, we can use these commands find library, and we give it the name of the library, and we're going to store the information in this object, all caps beat it here, and then we're going to also find the path to the includes. And for this, in order to find the path, it needs to be able to know the locations to search, and we'll fix that in a minute. And we're going to store that in this variable called beatit.inc. And then we have these two commands, target include directories. When it does the find library and stores it in beatit right here, all caps, it knows it's already found the library and associated with this variable. So when we do the target link libraries command, it's going to include the link directory in the build command, and we don't have to do that explicitly. But we do need to do it explicitly for the include directories. So this target include directories for our executable is going to include the location here that we stored in beatit.inc from this find path command. So that's some of the key differences with our previous example where we had find package, and then we just link against the package, whereas now we need to find the library and find the path to the headers, and then tell the executable about where those headers are in the link step and the build step, and then also the target link libraries here to know where it's at when it links the code together. Okay, and then finally we have the install command, and we just put it up a directory in the run. So let's go ahead and do that. mkdir build, cd build, CMake ... and it crashes. And it crashes because generate step failed, build files cannot be regenerated correctly. The following variables are used, but they're set to not found. It can't find it. It can't find where we put these things. And that's because it's in a non-standard location. It's up two directories, and user is where the library is. It doesn't know to look there. So the way that we tell it to look is similar to before, where we can do env, and we have CMake prefix path. That's the variable, the environment variable that CMake will use to search for these non-standard locations. And before we had example 3 and 4, so let's just add to that, export example 7. Now we can see that example 3, 4, and 7 are in there. And then we can go in and let's just start from scratch. CMake make install, and this time it works fine. So if we go up into the run directory where it was installed, it works great. Okay, and that's an example of building this external library, and then without the configuration, and then making an executable that links against it.